All right, we'll get going here. I'm a little alarmed because I feel like we're almost like a dozen people short today, which is not a great start to the semester. Um, so hopefully you're in the right place. I'm Professor Lantis. This is Econ E371. So introduction to econometrics. We'll kind of go over, syllabus type stuff today. We'll jump into a little bit of material. Also something that's going to be pretty important that we're going to be using in this class, and I'll kind of walk you through how to get that downloaded or how to use it on your device. So it's called Stata or Stata. We'll talk about it here in a little bit, but we'll just kind of start out with some syllabus stuff. So hopefully you're in the right place. So this week, like I said, I'm going to introduce the class. We'll go through kind of review of probability and statistics. So most of you probably took 370. Yes, no, yeah. Hey, who didn't take 370? Like a math equivalent? Anybody? You all took 370? Okay, perfect. Makes my life a little bit easier. So we kind of have a good base knowledge of statistics, probability. We're going to expand upon that and see how do we actually take that, develop some new techniques with it, and apply it to actual real world data. So what we're going to need for this class, and I also apologize, I kind of mentioned at the beginning, maybe trying to sit here. I'm not sure how great the view, especially if you're over here, you're going to see the back of my head most of the class. I don't know who designed this classroom to be like this, but I'll use the slides a lot. I'm also going to be using a lot of the dot cam. So you'll want to make sure you have a pretty good visual of what's being displayed up here. But we have a book for this class. I would not suggest going out and buying it. I kind of have all the materials created for this course that you're going to need. It's a good reference. It's a good, thing to have after you leave this class. But if I was making a suggestion, don't go out and get the 4th edition. You could probably find an older edition for like 15, 20 bucks, and it's basically the same thing. They probably just revise some of the examples and update some of the data sets they use. But for just having the book, I'm not really going to care about that. So that's something that I say is required, but I'm really not going to be teaching out of the book or anything like that. Right? But then I have to have a text assigned to the class. I'm really going to use all the materials that we'll be using for this class, whether it's slides, whether it's data sets, everything's going to live on Canvas, right? So Canvas is the main thing. I'll use it to post announcements. That's really our main hub. You will need some type of a device. It looks like all of you almost have something already in front of you. But I will be using some in-class stuff that you'll need a device, could be just simply as your phone, could be a computer, to kind of somewhat use class participation, which we'll talk about here in a little bit. But that'll be something that you would need for class. A basic calculator. Later on in the semester, I said for function here. I guess I should probably rewrite this slide. We might do some things like where we square something, although if you have multiplication, how would I square a number? Oh, Jesus. Multiply by itself, thank God. Okay, so, right, I mean, we shouldn't need anything crazier than that, right? Taking something to the second power. Excuse me. I'll post every week. You'll kind of see right now what I'm working off of. We go to the Canvas page. I try to set this up week by week. It's not really chapters because I'm not lining it up exactly with the book. So I kind of reference it as week by week. Here's the materials that we'll use week 1. I've got the slides up here already. So they'll always be there before we start covering. So next week, week 2 slides, you'll see week 2 pop up as what looks like a second. And a lot of these courses, they call them modules, right? But I'll upload those slides before we cover them next Tuesday. Okay. Now, the slides that I post this week is a little bit different. They're pretty complete this week. Some weeks I'll post what I call skeleton slides, where I leave some things out. Right? Now, I do that for a reason, because either I want to generate class discussion, or I want to kind of get your brain kind of thinking and not just giving you information. There might be some things missing. So that's where attending class is beneficial. You can fill in some of those missing blanks. Now, some of it, I'll post a complete version of the slides after, and I might fill in some of those bullet points. There will be plenty of slides. Week 1, I might not have as many, so this might backfire on me. There we go. Well, this is one. Here's one. There's going to be blank slides, right? Those I will not fill anything in. When I leave a blank or have a blank slide on there, it probably means I'm going to be doing something up here in the dot cam, right? If I can get my university funds to go through, I might even start getting fancy and hopefully my new tablet that I'll be getting this semester, start using it to kind of write with. But for now, I'm relying on kind of the good old dot cam, right? So none of that is going to be in the slides. So that's going to be something you need to be in class. And I'll do a lot of work up here, right? Now, I hesitate, especially like I said, with almost what I think is about a dozen people missing today to mention this, but I do think for those of you who want to utilize it well, it's a good resource. Every class period, I've got Zoom running, right? It's going to record what I'm saying. In fact, I need to get into the habit of things. Okay, the audio thing is moving, so I know that the audio is recording. I just want to double check that. Now, I tend to move around a little bit, probably a little bit less so in this class. I'm probably just going to randomly walk over here. Kind of weird. But it's going to be recording what I say and then anything that's on the screen. Now, it's going to be really helpful for when it comes to something we're going to use, which is called Stata, that works with data. But anything on these dot cams isn't going to get recorded in these Zoom recordings, right? So what I'll do is I'll just kind of have Zoom running. I don't think about it running at all, to be completely honest, which means it's probably not that great. But it is a weak substitute. We talk about strong and weak substitutes in economics. It's a weak substitute for being in class if you have to miss because you're sick or something like that. Or, like I said, when we actually work through some of the Stata stuff, it might be a good resource to always be able to go back to and see how do we work through that example in class. So I put the link up here. Another easy way of finding this, if we go to YouTube and we search Professor, there we go, Professor Lantis, right? I should be the first person that comes up. I've got playlists here. I only have one section this semester of 371. I've got kind of this starting Stata video, which will cover a little bit of how I go through it in class, but also be more like a help file when you're trying to get this program to work on your device. So this will be a good one. You can kind of go look at these videos. I won't have many like this. Occasionally I might post a little video like this where it's like a help tutorial or something. For the most part, it's just going to be the class recordings that I post up on this playlist. Okay. And once again, that link is in the slides here, and it's also in the Word document of the syllabus, which can be found on Canvas on the homepage or under the Files tab. Any questions for anything I've said up to this point? Stop me if at any point I say something that's confusing or you're not sure on. Okay? All right. So what do you care about? How are you going to get the grade that you want in this class, right? So this course honestly isn't as heavily weighted as exams as even like I teach the big like 251 side. I've had a couple of you work for me. So I teach the big 251 sections, like 300 students, a little bit heavier weight on exams even in that course. So it's only gonna be 60% of this course's grades come from exams. So a midterm and a final, right? So the midterm will be in class, right? I've got the date later on. I forget it off the top of my head. But we'll be in class, kind of taking that midterm, and then the final, we have kind of a reserved time slot from the university, which I also have kind of later on here, okay? So each one of those is going to be weighted equally. Now, I would say the finals, it's not comprehensive in the sense that, you know, I'm not going to ask you, I'll explain this later on in the class, okay. I'm not going to ask you like the types of questions I was going to ask you like in week 3 or 4, but everything in this class builds on itself. So I can't really talk about the second half of the class without the first half, right? So it's not going to be cumulative in that sense, but it is going to be comprehensive in the sense that we are constantly building on what we're learning in this course, week to week, okay? I'll also have Canvas quizzes. These will be about every 2 weeks or so. They'll be over kind of the previous 2 weeks material. Those will be 12% of your overall grade, and we'll dive into these categories a little more in depth here in a second. Problem sets are going to be a pretty big chunk. So total, this is almost the same weight as an exam, right? So these problem sets we'll have throughout the semester. This is going to be actually working with data, right? Using data sets to answer questions. They're graded for correctness. So are the quizzes, right? It's not just a matter of turning it in. You actually have to do it correct. And I think if I remember right, I'll have 6 of these problem sets throughout the semester. So like I said, about every 2 to 3 weeks, you know, with the exam day in there, it gets a little bit longer in between some of them. The first one might be a little closer to the second one because we don't cover quite as much material, and it's really just to kind of get you started. But these are going to be really, really important, and I'll try to provide as many materials for you with these as I'll mention here in just a second. And then kind of the only other thing that you're going to be graded on is what I'm calling kind of in-class quizzes, or it's basically attendance points, right? Now, these will be quizzes I use in class, and they will be graded for correctness, although just by simply answering the question, I'll give you half credit, and then the other half comes from getting it correct. So if I ask you, 2 or 3 questions, right, half of it just comes from answering the question, so physically being in class and answering it that day, and the other half comes from getting it correct. Now, if you're in class, I like to give strong hints, and if you're paying any amount of attention to the class at all, it's likely you're going to get a lot of these questions correct. So these really should be kind of purely effort-based points. Now, it's only 4% of your overall grade, but when it comes to those cutoffs, thinking about going from a B minus to a B, B plus to a minus, that's usually kind of what can be the deciding factor, right? If you're missing a ton of classes, it's probably not going to help you kind of get past those thresholds if you didn't do so well on some of the exams. However, if you've attended every class, you've gotten a majority of these points, that can kind of help you, if you're close to one of those cutoffs. Okay. So a little more in depth in each one of these. So the quizzes, I said they're about every 2 weeks, right? So we should have 6 of these by the end of the semester. So usually I'll assign them on a class or after a Thursday class period, right? You're then going to have until the following Tuesday, right, by the start of class to complete them. Okay? So you only have, 4 or 5 days, right, to get on and get them done. But up to that point, we've already covered all the material that you would need. I've already given you some practice problems that look similar to some of the types of questions you would see on the quiz. So you can start looking at those, not just the Thursday that the quiz is assigned. Those will be up well in advance of that. So you can kind of start taking a look even before that quiz is made available to you. Right? Now, so the start of class, 12:45, we start class here. So, hopefully you guys get a little bit of a break. I'm not making it do it like the end of the day. If you wake up Tuesday, no, totally forgot I have an econometrics quiz, you can get on and get it done that morning. Okay. Each quiz is going to be worth 2% of your overall grade, which doesn't sound like much, but right, is a total of 12%. Once again, these are going to be like open notes, open YouTube recordings, open everything, right? It's just a matter of you have to get on Canvas. So this is where the quizzes will be on Canvas and get them completed and get them correct. Okay. So you should have, these quizzes are going to be a lot easier than exams because you have all these resources available in front of you. Okay. So take them seriously. Try to get as many points possible as you can. These quizzes to kind of help it to make it so that the exams aren't as stressful. Okay. Class participation. So it's not required, I guess, technically, because even though I'm going to give these in-class quizzes, they're going to be somewhat random. So it's not going to be every single class that I use these. Right? So I think I said 12 total throughout the semester. So it's about every other class period. Some weeks I might not have any. Some weeks I might have 1, right? Sometimes they'll be Tuesdays. Sometimes they'll be Thursdays. Sometimes they'll be at the beginning of class. Sometimes they'll be at the end. Sometimes they'll be smack dab in the middle, right? They're going to be all over the place, right? So each one of these will be worth kind of a total of 4 points. So how do I get a total then of 4% of your overall grade? I'll drop your 2 lowest, right? So you can miss essentially 2 class periods and it's not going to count against you. In fact, technically, if you miss the right class periods, right, the ones that I don't use them on, you can miss more than 2. But this is a way that even if you just so happen to, by dumb luck, miss the class periods that we have some in-class quizzes on, it gives you essentially like 2 sick days there, right? So I always explain this method. I think this is what every professor should use because it's like real world, right? If you have to call in late or if you have to call in off work, you have to use a sick day. They don't just say, oh, it's okay, we'll still pay you. No, like you actually have to use what they give you, which are sick days, which essentially have 2 here. Right? Now, this doesn't happen until the end of the semester. So until we get to the end of the semester, it's going to look like it's negatively impacting your grade if you miss 1 or 2 of these, right? But if you happen to miss 2, your 2 lowest scores will be zeros. Those get dropped at the end of the semester. I wouldn't suggest planning on missing classes because these aren't just simply being in class. Like I said, it's getting the answer correct. Half the points are for just being here. Half are just effort-based, but half are actually paying attention in what we're doing in class and then getting the answer correct, okay? Any questions on this before we keep moving? So the way that I'll use these, I don't think I put a slide up here. It might outline this a little more in the Word syllabus. I'm going to just use Canvas to do these. And so theoretically, if you wanted to sit in your apartment or dorm, wherever you live, and refresh Canvas for the entire time of class and not show up, I guess technically you could do that, and you might, see me manually deploy these and then manually close them and be able to answer them. Although that's not going to help you get them correct, right? You might be able to, that would help you get, I guess, half for attending, right? But I said, they're going to be random. Sometimes they'll be beginning of class and middle. So it's not, the real way to guarantee that you're going to be able to answer the questions of these quizzes, which may only be open for 5 minutes, 5 to 10 minutes in class. I wouldn't even think 10 minutes would probably be a little bit long, is actually being here, seeing me manually deploy them, get on Canvas on your device, and answer the questions in the following, say, 5 minutes that I give you to work on them. Okay? Does that make sense? There's probably way more technical ways of me doing that, have you guys pay for some platform and then use proximity Wi-Fi. I think this gets at it pretty well. Okay. Any questions on that before we keep moving? Okay. So just like we have 6 quizzes, there'll be 6 problem sets. They're generally, the overlap is not 1-to-1, so it's not like they're always going to have the same due dates or the same assignment dates. I, in fact, try to stagger them a little bit, right, so that we don't have like a quiz to study for while we're trying to get a problem set turned in at the same time. So starting off the semester, I think the first 2 kind of coincide a little bit, but from there on out, they're kind of staggered a little bit. Usually, when I assign them, you'll have roughly 2 weeks to complete. This changes, like I said, early in the semester, probably closer to 2 weeks. Towards the end, there might be one where you have closer to 3 weeks, right? Just kind of depends on how much material is on those problem sets. So we're going to use a program called Stata. I call it Stata. Sometimes I'll call it Stata, data. It's essentially that, right? I don't even know at this point what the real correct way to say it is. We can probably Google it, but I interchange, go back and forth, right? So you can find this on IU Anywhere, and I'll walk through the steps here later on in the class of how you can actually access this. But what these assignments are going to be is I will give you some data sets and then kind of give you a Word document of questions that you need to answer. The only way you can answer them is not by simply like looking at the data. You have to use this program to start to do things like calculate means, determine what standard deviations are. Excuse me. Eventually, what we'll do is start running regressions and using the output that the program gives you to then answer the questions. Okay. So what you're going to upload for these, let's see if I have it here. No, I just have how much they're worth here. But ultimately, and we'll talk more about this once I assign that first one, and once we have kind of everyone makes sure they can kind of access and get on and get Stata working. But you'll upload both your answers in a Word document, or there's these files, just like Microsoft Word, it's like a .doc file, right? Stata, the files that you're going to upload, you're going to have all this code that runs in the, that you will run to produce these different statistical results. You'll upload those, what we call do files, right? So I think this will be a little bit more clear once we actually get to that first assignment and we've worked through some stuff in class that I can reference. But you'll either upload both your do file and a Word document, or as we get more familiar with it, a lot of people, there's ways you can insert comments and stuff, and they'll just upload the do file. It'll have all of their code as well as what the actual answers to the questions are, okay? And like I said, this will be a little bit more clear as we work through more stuff in class before we get to that first assignment. So each one's worth 3%, 6 of them kind of, oh, wait, that's not working out, right? Can I not do math in my head, I guess? We'll probably change this from the other semester. There we go. 24% of your overall grade. We have 6 of these problem sets, right? Each one being worth kind of 4% of your overall grade. So it's a pretty good chunk of your grade. I want you to take these seriously. This is going to be the skill. If you're like, this is me going on a bit of a diatribe, but grades matter. Getting your degree, obviously, if you want to pass your classes, enough to be able to graduate. But your success once you graduate is not going to be directly because you got all A's and B's, right? It's going to be how well did you learn the material. So it doesn't matter if you like finagled your way into an A in certain classes by cutting some corners, using ChatGPT to do some work for you, right? If you don't know how to actually implement it once you leave, it's not going to have a huge benefit to you when you're out there in the workplace. So this is the probably area of the course. Obviously, you need to understand the concepts that I'll kind of test you on the exam. And the exam will have a lot of stuff from Stata, but this is the skill, like working with actual data in a data management program. is probably going to be what's the most beneficial to you once you get out of this class. So I would take these seriously. And anytime you can put like you have coding knowledge, even if it's very minimal, it's going to set you apart from a lot of people. Okay. So that's why I'm using it. Here's just some important dates. These are in the syllabus as well. So I think I've got withdrawal dates. I've got spring break. We have just to know we won't have class that week. But the in-class exam is March 6th. So it just so happens that the midterm is March 6th and the final is assigned to us to be May 6th, right? So these will be kind of our two exam dates. This one I can't really change. This is given to us by the university. Obviously, if there's some conflicts or something as we get close, maybe we reach out to me and we can work on something. But this is kind of the expected dates that I have for you, that you'll be able to be in class on March 6th to take the midterm and available during this 2-hour time slot during finals week to take the final. Okay. Any questions on that? Okay, pretty straightforward. So how to succeed in this class? So I said read the book here. Read the book. Really for us, our book is going to be kind of the slides. So I think one thing that can be helpful is just kind of combing through the slides since I put them up there early, just to kind of get an idea about what we're going to talk about that week. Even if it doesn't all make sense, just kind of look through it, see some of the terms, just see kind of what it's looking like, especially as we have somewhat of a base of knowledge. You'll be like, oh, that looks kind of similar to stuff we've done, but this is different. This is different. And it just kind of primes your brain for what we're going to talk about that upcoming week. Okay? Show up to class, those free, really effort-based points of those in-class quizzes. Doesn't sound like it's much of your grade, but like I said, it really is the difference between kind of being on the wrong or right side of cutoffs usually. Okay. Practice, practice, practice. So you can use the end of the chapter questions in the book. If you don't have the book, I don't think that's overly important to have the book and work through those. They're just an additional kind of resource. But I'll put up practice problems that go with these quizzes. Those are going to be really good ones to review. As we get closer to the midterm and the final, I'll have practice exams with sets of questions that you can work through. So always just working through more problems is the best way, I think, to learn really most economics classes. That's going to be the best way to learn the material. And so I'll try to provide as many resources as possible. Anytime we have a quiz or exam, there will likely be some set of practice problems that goes along with it. Okay. I say more than likely, there will be a set of practice problems that goes along with it. Okay. Take those Canvas quizzes seriously. I kind of already hit on this one. Have materials in front of you. Look at the practice problems ahead of time. Ask me any questions that you have after the classes that we've covered the material before you sit down to actually take the quiz. Using office hours, so they're open note. So, also I have to mention, be very aware of the due dates. So I'll try to use Canvas. That's, like I said, that's kind of our main thing. I'll try to mention due dates as much as possible in class. Zeros kill your grade, especially when there's only 6 problem sets or 6 quizzes. Missing one of them is huge, right? And there's no late kind of work in this class. So if it's not turned in by the due date, barring extenuating circumstances, right, that's going to really start to have some negative influences on your grade, right? So even if you don't have a lot of time, you've got other courses, I get it, you got a lot of other projects, maybe you were only able to take like a half-ass effort at one of the, well, 50% is a lot better than 0. That's not, we'll talk about averages. 50 will pull the average down, not near as much as a 0, right? So make sure you're at least kind of taking, your best effort at these, even if you know that a couple of problems, maybe on the problem set, I'm not really sure what I'm doing here, at least work through as much as you possibly can, okay? Don't be afraid to ask questions. That means in class as well. I don't like to just be the only one talking. It becomes pretty boring. And also, I don't know what you're not quite understanding if I don't hear back from you. So always feel free to stop me during class, ask questions. I have a GA for this class. I asked them to get their office hours to me by the end of the week, so it's not updated here yet. But I think their name's in the syllabus. But they will have office hours that I'll get posted. I'll update the syllabus and these slides. Like I said, I told them to try to get them to me quickly, but I gave them to the end of the week. So for sure next week, these will be updated and have those office hours in them. If you don't like talking to professors, sometimes TAs are a little bit more, I don't know, they're younger and I don't know, maybe it's not as scary or something. I don't know. But that will be available to you, their office hours. My office hours are going to be Monday, Wednesdays, 10 to 11:30 and 1 to 2:30. So I'll also throw in this caveat. I teach those big 251 sections, so I have a total of like 600 students. So my office hours, first come, first serve, sometimes are, you know, it's not great, right? You might end up waiting a little bit. So I'm always available by appointment. And what I don't tell them that I'll tell you, these aren't like hard and fast times. And so, you know, if you know that like 2:30 might work for you, well, everyone else is going to be out by 2:30. If you want to show up a little bit after 2:30, I'll likely be in my office. I can't promise it every single day. I've carved out these times for sure to be there. But we can likely, if you send me an email like, I can't quite make it, you know, at 2, or I'll be there right at 2:30. Always feel free to kind of email me and set something up by appointment as well. Okay. Another good time to ask questions. Most days probably be following class. I don't have a lot of things that I try to schedule from 2 to 4 on Tuesdays and Thursdays. So after class is also another good time if you are available to kind of shoot me an email and, hey, can we meet after class, or just talk to me after class. We've got 20 minutes till the next class gets in here. I can probably answer some pretty quick questions. Okay. Any other questions on that? Yeah.
In class, is it better to take notes, pen and paper, or it just doesn't?
So it's probably individual specific, although there's definitely going to be some things that I draw out. I mean, if you have a good program for drawing on your laptop, then it's like, you know, it's not as extensive as this, but like drawing out supply and demand curves. We're not doing a lot of that, but just as an example, it's probably, for me, not as easy to draw it out on my computer with like a cursor mouse as it would be just to draw it out with pen and paper. And I don't know, to me, there's always, I haven't really dove into the research to whether this is true, but it feels like for me specifically, when I write things down, it sticks in my mind a little bit better than if I'm just typing it in a Word document. I don't know if there's any research to back that up. It may be, you know, we'll talk about distributions. I might happen to be on one tail of the distribution. It's really individual specific, but yeah, I think writing things down, whether or not it wants to be whether or not that has to be pen and paper, you can also kind of have a Word open and, you know, or whatever program you like to kind of take notes in. Probably about the same. Any other questions? Also, my office, just to mention, is over in Wiley, up on the 3rd floor. So just on the other side of the chemistry building here. Okay. All right. So help me help you. We can get to this. I'll end class with this. So let me skip ahead and we'll come back to this. So what's the goal of this course? I'll kind of set some things up. We'll talk a little bit about statistics today, and then I'll also jump into how do we use this program Stata. All right. So, you know, one major thing that we want to know in economics is causal effects. Right. So if we increase taxes as the government, what do we expect to happen to prices? Oh no. We increase taxes, prices will go up, right? You're adding a cost to something, you're shifting either the supply or demand curve in a way that it should increase your prices, right? So that's a causal effect. We can look at data, we can look at different tax amounts. In fact, you can actually go out and grab some cigarette tax data, which I think is one of the data sets that I have. You can look at, as that cigarette tax goes up, what happens to the overall price per pack? It also goes up. And we can pick up on this correlation, okay? Now, what our ultimate goal is by the end of the semester is we don't just want to pick up a correlation. We want to make sure this is causal. So I'll give you another good example. So let's say that I'm looking at the correlation between hours studied in a very basic, like micro, you know, whatever, what are we, 251 microeconomic, or I forget what it is for, is it E251, right? Or E201, I forget the exact number, but is the hours studied each week, does that have a positive or negative correlation with exam performance? What if you look at the data and you're like, oh, looks like as the hours studied goes up, there's actually a negative correlation with exam performance. So there's a negative correlation. Do you think that means that as you study more, the cause is that you do worse on exams? No. What type of students might have to study more? If you're really smart, how much do you have to study? Very little. If you're not as smart, what might you have to do? Study more, right? And so there might be some outside factor that's related to both of these things that makes it look like they're having a positive causal effect, but it's just a correlation, right? So we want to disentangle those two things. Is it a correlation or is it actually causal, right? I mean, I think inherently we know if the same person studied more, they're likely going to do better on the exam. But, you know, it's equivalent with a negative correlation if we just look at raw data, right? So I think I've got some other examples here. So I have some data sets where we'll look at class size. So if you think about classes of 30 versus 100 versus especially like the elementary and then high school levels, if we have larger class sizes, what's likely to happen to student test scores? Well, each student's getting less individual attention, and so we might see test scores go down. We can look at things like, we'll call them indicator variables, but do we see that individual's race, right? So if we just have like an identifier for was this individual of a certain race, did that have positive or negative impacts on their mortgage, right? The mortgage rates they were getting? We have ways of identifying essentially discrimination, right? So we'll look at this in a lot of different contexts this semester, and thinking about how we can use data on race to actually identify whether or not we're seeing discriminatory practices going on. Right? I already kind of mentioned the cigarette tax is one. Does it actually reduce smoking or does it not? So I'll give an example of a tax that works the opposite way. So I think it was Ireland started taxing like plastic bags, like from Walmart, like the really thin ones, like because we use them and we just toss them. You see them floating around out, you know, people litter all the time. So they're like, oh, we'll start taxing these plastic bags at stores. People will be more likely to use paper bags. People will be more likely to like bring their own reusable bags, like sturdier ones that they'll reuse over and over again. What actually happened was when they increased that tax, instead of reducing, right, people have to pay more money. Instead of reducing the quantity of plastic bags used, it actually increased it, right? Why? Because before, people felt guilty if they littered these plastic bags. Now that I had to pay a tax for it, I don't feel as guilty. My actions change. So we never know, you know, we're going to try to disentangle some of this. Is it a causal effect or is it just correlations? Right? So just a little bit more of a different kind of example. We can also make predictions, right? So looking at more like macro level stuff, we can look at historical data and say, okay, based off of the current conditions, can I predict what the GDP is going to be for the US in 2024 or 2025 or whatever the year is, right? Like could have I predicted the previous year's GDP based off of all the you know, different measurables I have of what the income going into the year was, things like that. So we're not only going to try to understand relationships, we're also going to try to make predictions is a big part of what we're going to be doing in this class. Okay. So just to outline a couple types of data sets that we'll be looking at, and then I'll kind of jump into data and look at kind of outline how we use that. So where are we at in time? So we got what? 40? Oh, we're good. So some data sets we'll be looking at, we'll call cross-sectional. These will probably be a lot of the first ones that we start out with. They're a little bit easier. So this is going to be when I have one point in time and I have multiple subjects recorded. So this might be something like, I collect all of your GPAs today, like what they currently are. I've collected one variable, one data point, which was your GPA for a bunch of different subjects. Right? I've got 30 plus students in here, but at one point in time. That's cross-sectional data. Time series data is going to be where I collect information on a variable or something I'm interested in for one subject at multiple points in time. So this might be I choose you and I see what was your GPA for every semester that you were in college. I've now got one subject, one element. I don't usually use that term, but that is a very like subjects. That's what like an economist would use. Elements, that would be like a true statistician would be calling those data points that. But basically I have one subject or element recorded at several points in time. Or this would be like, I have one country and I've collected what their GDP is for the past 50 years. That's time series data. Now I can mash those two together and come up with these more expansive data sets, which are panel data sets, which is I have multiple subjects at multiple points in time. So maybe I have every single country in the world and what their GDP was for the last 40 years, right? So that's kind of panel data. It's kind of the combination of the two. Okay. So a lot of data sets we'll start out with will be cross-sectional. Which of these do you think probably gives us the most power statistically to do like to be able to answer the most questions? Well, which one seems like you have more information?
Panel.
Yeah, panel, right? I now have multiple subjects at multiple points in time. We can start to do some pretty cool things with panel data that we can't do with these other data sets. But we got to walk before we can run. So a lot of times we'll start out with some of these time series and cross-sectional. So just to kind of give you a visual of what some of these look like, you know, here I've got cross-sectional data. I had what the population was of the top 20 cities in the US, right? So multiple subjects, 1 point in time, right? 1 year. Cross-sectional data, another example. I don't just have to have one variable. So here, I'm simplifying it. We just had population was the only thing that we were recording, right? You can still have cross-sectional data, right? Multiple subjects. So now I've got multiple countries. It's still 1 point in time, 2011, but I can have multiple variables collected. So kind of each column that we have in our data set represents a different variable, right? So here I've got what? GDP per capita was one thing that I recorded for all of these countries in 2011. Primary education expenditures was another variable I had recorded for every single country in that year. And then secondary education expenditures was a third variable. So cross-sectional data sets, it doesn't just have to be one variable that you're collecting information on. It can be multiple, like this could be hundreds of variables. It's just that they're all collected at one point in time for these several subjects. Okay. Same kind of idea. I could have the US, the time series data, one subject, multiple points in time. I have their unemployment. I have the US unemployment. Well, I don't just have one variable here. I could have the US's unemployment in these time periods as one variable. I could have their GDP as a second variable. I could have, what's another thing? Maybe, I don't know, what the inflation rate was in that year. I could have multiple variables for every single time period just for one subject. That would be a time series data set. Excuse me. And then I think all of my students are starting to sample or age out of this data set. Hold on, let's think. 13, yeah, probably. So how many of you went to like, I don't know, elementary or grade school in Indiana? A few of you take the I-STEP? Yeah, right, the state makes you. So there's this, you know, every state has their own test. I happen to have an old I-STEP data set. And basically, I don't have names, but I have student who had the identifiers 1, student ID 2, 3. Every single student in Indiana was given a specific number. And then I have what their I-STEP score, math and reading score was every single year. So I have multiple subjects and I have multiple points in time collected for each subject, right? This would be a good example of a panel data set, okay? And once again, with panel data, we can have multiple variables. I have 2 types of test scores recorded here. I have their grade collected. Looks like this person might have failed, or there's just an error in this data. I've got their gender collected, right? So we haven't talked yet about different types of variables. They don't always have to be numerical. Sometimes it'll be what we call qualitative, where it'll be like words, right? Or here it happens just to be letters. I have school as, you know, another variable that we have collected, okay? So these are some of the different types of data sets that we'll look at. I want to make sure that we have time to walk through kind of how to get Stata onto our devices. If we still have time at the end, I might kind of start to do some of this basic, well, is that going to be problematic? Got 25 minutes left. We'll go over a little bit of this. I'll just kind of outline some terms and then we'll kind of switch gears a little bit. So when we're dealing with these data sets, we're going to have 2 different types of data sets that start to matter for us. So one is going to be population data. So we'll kind of use the number of observations in our population data set as capital N. So if you remember from 370, you have population data and you also have sample data, right? So skip ahead here. Do I have it? No, I think I have it later on. So we'll start out just thinking about how would we deal with population data. And then we'll talk about what if we only have a small sample, how do things change, right? So I don't know, I've got some examples here, like every single, you know, if I had population data and I had let's say I wanted to know the average height in the US or the mean height, I would literally need every single person in the US's height. Right? That's population data. If I wanted to know what the average life expectancy was in the world, I would need life expectancy data on every single country in the world. If I wanted to know, what are the average mile per gallon for every car produced, I would need information from every single automotive company, right? So population data is every single subject that would exist that you could collect information on that variable for. Okay? We're also going to talk about not just having population data, but we're going to talk about random variables. So I'm collecting information on these populations for some variable. And let's say I wanted to do life expectancy, right? Well, I know that it really, if I'm calculating like the mean life expectancy in every country, what are all the possible values that I could see? So let's say the US has a life expectancy of, I don't even know, 78.3. What's a value I can see for another country? I mean, if I choose another country at random, do you think it's going to be exactly 78.3? Probably not. Maybe it's 74.2, or maybe it's 81.9. However, we know that we could see all kinds of different values for this variable, but what's the likelihood if I chose a country at random, I see their life expectancy be 75, compared to the probability if I choose a country at random, their life expectancy is 20. Well, I pray to God there's not a country where the average life expectancy is 20 out there, right? We know that that's going to be a lot less. It's still a possible value we could see theoretically, but we know the probability is very, very small, and the probability of seeing a value like 75 or 76 is much higher. So we're going to start to think about, yes, we have these random variables, and they can take on these values in this range, but some of the values in that range are going to be more likely than others, right? So we can start to associate probabilities with different values for these random variables that we're collecting data on. Okay. So we're going to start doing things like, okay, maybe I've got something that's nice. Like maybe what would be a good one here? Oh, let's say the number of purchases a month from Amazon, right? And I choose a person at random and I want to know how many purchases they make from Amazon this month. Well, here I could say, what's the probability that this random variable Y, I know it could be anywhere from 0 to, I don't know, hundreds, right? Depending on who we're looking at. Well, what's the probability that this person had exactly 10 purchases, right? And I can compare that to what's the probability that if I select a person at random, they had exactly 20 purchases from Amazon, and et cetera, et cetera. Now, can I have 20 and a half purchases? No, I either purchased something or I didn't. And so this would be what we call a discrete random variable. I can only see integer values, right? I can go from 0 to 1 to 2 to 3 to 4 purchases. Can't have 1.5 purchases. Right? It doesn't really make sense in the context of the variable that we're collecting data on, right? So what that would look like, I think here you can think about, I use the mass score data here, but we could use the Amazon example. We start to get things that kind of look a little bit more what we would call disaggregated, right? We kind of have jumps, right? We don't have this nice kind of continuous line. Now we can also have continuous random variables. So maybe I want to know, well, how much, what's something that would be between 10 and 20? I should have had an example in my head for this going into class. What's the probability if I select somebody at random? What's the likelihood that they've spent between $10 and $20 on, like, not takeout food, but like food from a restaurant or something that day? Well, they could have spent $10.53. They could have spent, $19.69, right? I've got a lot more of a continuous variable there where I can see all kinds of different values in between 10 and 20. And so there with continuous random variables, I'm looking for not the probability of one specific value, but the probability across a certain range. And my example actually isn't perfect, because technically the amount of money I spend on food would be what? Could I ever see $10.63, 4, 5, 6 cents, right? It only goes to that second decimal. So I truly would need something like, let's say I had like a very perfect measure of height. If I could measure human height out to like whatever decimal I wanted, it's truly continuous, right? As long as I have a good enough measurement tool, a lot of things that we have would really be continuous variables. So if I had a truly continuous variable, I could see, Someone is 63.15758923 inches tall. What's the probability I see one specific value from a truly continuous variable? It's truly continuous. I'll break it down. Even if we think about something like height, let's say everybody was in between 70 and 71 inches. How many numbers are in between 70 and 71? Any math geeks here? If I can go out to any decimal, how many numbers are in between? Infinite. So if I have an infinite set of numbers, the likelihood of any one number would be what? 1 over infinity. What's 1 over infinity in the limit? So the probability of any one value, if we have a truly continuous variable, would be 0. So we can only look at probabilities over ranges, right? Infinity is weird. We won't deal with it a whole lot in this class. So that's just a way for me to set things up today, right? But we've got continuous, discrete random variables. Our continuous variables, we start to get these what look a lot more like what you probably saw in 370, right? Normal distributions, nice continuous lines, okay? All right, so we'll set that up. We'll go over some more of this stuff next class because I want to make sure that we have time for me to show you how we set up Stata. So we're starting to think about data sets. I want to show you this program that you can start to open them up and calculate things like means, standard deviations. Hopefully these sound a little bit familiar from 370. So the first thing we're going to need to do, and let's see if I can do this from memory off the top of my head. So I believe the first thing we'll need to do is go to cloud storage, right? So I guess that's a second. Go to 1.iu. So we go to 1.iu, search for this cloud storage. It'll be right here, right? Now, I've already got some of this, so I'll kind of talk you through how you do it. You log in. So let's see if I can type my password out correctly the first time. So notice I've got a check mark next to this OneDrive IU. I think probably at this point, hopefully in your college career, hopefully you've done this for other classes or for something. If not, you need to make sure that there's a check mark here. If there's not, when you click on this, excuse me, instead of deauthorize, it should say authorize, right? If it says deauthorize, that means you've already got it connected, right? So you go to 1.iu cloud storage. And then next to that OneDrive IU, you'll make sure that you've authorized it. And it then should pop up with a green check mark next to it. Okay. Is anybody walking along with me or no? Yes. Is that working so far? Okay. I love feedback to confirm that I'm not just like talking past 5 steps past what's not working for you guys, right? So we've got cloud storage now set up. So the next thing that we're going to go do is go 1.iu and search for IU anywhere. Have you guys used this in other classes? Seen a couple heads nod. So we'll log in once again. Now here, if you haven't downloaded this yet, I think it will still prompt you. This is where it's hard for me to go through it exactly. It'll still prompt you to detect the Citrix workspace. Notice, because these computers get wiped, I think this is what you should see if you don't already have it like downloaded or you haven't used it for another class. So if you haven't ever used it, at this point, you'll have to go, I agree. If you've used it before for another class, when you detect it, it should send you somewhere else, which we'll see in just a second. So here, I'm going to have to download it on this computer. Wait for it to download. Don't get antsy, because if you hit this before it downloads, it's a hassle, and you got to sign out, sign back into your computer, and like go through the process again.
What did you type in the page?
I just went to IU anywhere. Yep. So now that I have it downloaded, so the download is complete up here. I'm going to hit continue. All right. Please wait while we confirm, blah, 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 blah. So it looks like, why isn't it detecting this? Let's try to go to detect again. Oh, maybe actually already installed. There we go. So if you download it, it kind of gives you that prompt. Sometimes detect again will do it. Sometimes it's just you say it's already installed. Once you see the installation occur, you might have to click one of those, and then it'll send you here. If you already had it downloaded from other classes, it should have, when you went to detect it, it should have sent you right here. Did it send some of you guys here? Yes? Okay. But if you hadn't already had it downloaded, you had to go through those additional steps. Now that we're here, we'll go to apps. Unfortunately, ours is very far down, so we'll scroll all the way down to this Stata or Stata SE18. This is the latest version of it. Click open. Kind of see this pop up here. Kind of give it some time to think. You shouldn't have to click anything here. It usually will just take some time. See if it's online. Might have to click on this. See if it gets going. This is because it's a university computer. Well, I don't think most of you should usually have to go through this step, but it might because these computers get wiped every day. Although this should already be set up. We'll see if this works. Try to be patient here. If you've got this on your own individual device, did any of you open it up for you when you clicked on Stay to Open? It should kind of be okay. Like I said, on my personal device and other ones, I usually have it work fine. So let's see if I get this. I think it's got some pop-up blockers on here, which is why it's having me. Yeah, so this is what it should do when you can hit open. I had to go through an additional step. I must have a pop-up blocker or something on this computer or on this device. So it's running through this stuff. Thinking. Oh. All right, there it goes. All right, so finally open up the program, right? So once you get this kind of set up where you can open it, it won't take as long every single time. But this is the actual program that we're going to use, okay? So were some of you able to get to this point? Anyone run into any snags? Like I said, the main snag I've run into when downloading Citrix is, like I said, sometimes the pop-up blockers prevent it from like opening the different programs that you select. If you're having any issues with it, let me know. Like I said, the first assignment won't be for a ways out, but I will start using this in class, even right now, but Thursday we'll use Stata as well. So try to get on, use that Stata, that video that's on the YouTube page as well, that kind of walks through the steps of how to get it kind of downloaded, how to make sure everything's working correctly so that you can get to this point. Once you're to this point, it's basically just like you have the program on your computer. So here's what it looks like. I'll show you a couple things you can do, and then I'll show you better ways to do it. So, excuse me. I want to go to our, not here, Canvas page. So I only have one file up there right now, which is a .csv file, so you can open this up in Excel, right? I also have under the week 1 materials, week 1 data files. I've got some other files as well. So you'll notice this is a .dta file. So if I just want to open a data set, it has to be in Stata's like form. That's a .dta file. Now I can open other data sets like CSV or Excel files that I have up here. I just have to import them and it has to convert them into a data set that is a .dta file. So if I'm on this interface and I go to File Open, if I've authorized my OneDrive, I should see my OneDrive as a possible kind of file path that I can get to. So I'm going to click here, wherever, create a folder, ECON 371, I don't know, files or whatever you want to call it. Once you get, I've got mine kind of several folders. Here's these .dta files. So if you go to File Open, the only thing that's going to show to you are these .dta files, which are actual data files already in the correct format, or what I mentioned earlier, which was these do files, which all they do is save your code, okay? So I'm going to open up this MBA height data set just to kind of show you what it looks like. notice when I open it, it spits out a line of code at me. So if I were to type, and it goes onto two, because my screen's not big enough, but this is like, should just be one word height. It's just that it's showing me it's going down to the next line. If I typed all of this out again, right, so I'll even kind of show you here. So instead of going through that nice interface, if I had typed out this command, and since I already have a data set open, I have to add this. We'll worry about this later. And I hit enter, whatever code I put in this command box, it'll run that, and it opened up that same data set. So I think probably the easier way for us, especially starting out, you can just use this nice interface up here, file open, and open up whatever Stata file that we're using. Now, if I want to look at the actual data, notice here, it tells me the different variables that I have. So height, defensive, offensive rebounds, etc. But I can't see the actual data. All I can see is where, what line of code I ran to open up that data set. If I want to look at the actual data, there's these two icons up here, which are the data editor and data browser. I try to, out of good practice, never select the data editor, because we don't want to just be manually changing the data, right? It is what it is. We just want to observe it. So we'll go to the data editor. It then pops up a separate window, which I can now look at the actual data set. So I've got all these different players. I've got their age, weight, games played, all these different variables. And I've got it for every single NBA player here. And whatever, I forget what year this was. But this is basically my data set. So I can kind of look at my variables. I can see how many observations I have. In fact, here, how many observations do I have? 1,054, right? So that's the actual data set that's open behind the scenes, okay? Now, the actual program, this is just where I'm going to run code that does things to that data set, whether it uses the data to calculate a mean, or uses that data to calculate a standard deviation, or all the different things that we're going to do. Okay. So our output from our code will always show up here. But the actual data set, right, that it's using, you can kind of also view in a separate window. Okay. Any questions on that idea? I want to go slow here because I know this is a lot to start out with. You've got the data open, you can start to do things to it. We haven't done anything other than open it to this point. All right, so once you have that data set open, the next thing that we'll start thinking about is if I were to close out this program right now, anything I type out here, so let's see, call this mean age. So I can start to create, well, I can remember what they are. EGen, mean age. I can start to run code and it'll do things like create a new variable that calculated the mean of the age from this data set and put that in the data set. Well, don't worry, I'll go over this again next class. But I'm just saying you can start to type out code and have it do things, add things to the data set. Promise if I close this out, it all goes away. So what if I want to save this? Well, that's what we're going to have this do file for. So if you go up here to this little notepad and you click on it, it'll open up another window, right? Which is, to be completely honest, if I'm working on these assignments, having multiple screens is really helpful, right? Because we have multiple windows here that we're going to have. So here's what we call the do file, right? So what we do in this do file is even if I want to type things in the command box, if I copy and then paste them here, I can now save all of the code that I was running. So I can go and save this. Call it class example. And notice it's saving it as a do file, right? So this is where I'm going to save all of my code so that if I want to close out of the program, come back to it later, I can open my do file up and it has all of that saved code that I was running in this command box or over here in the actual program. Okay. I could copy and paste this as well, right, and save that or all the work that we've done. But really that do file is where you're going to want to save all of your work. Now, one thing that's nice is I don't have to go through this process where I type it out, highlight it, copy it, paste it. if you have the do file open, oh, let's think, standard deviation of age. No, this is, well, I know the variance, hold on. This is worse syntax, I should probably be better than I am. All right, so I've got, here I'm gonna calculate the variance of age. Oh, what didn't I like about this? Egen, their age. Okay, there we go. The whole, I have to type the whole name. I've been working in R too much. Oh, what didn't I like there? Just to show you something. The sample variable. So if I type it out here, and then I click, well, not to rename it something new. So if I've got my code here, instead of typing it out in the command box and then copy and pasting it over, if I just type it out in the do file, I then select it and go up to this little play button, it'll run that code for me and then create this new variable. Now, all this did was create a variable that's equal to 1 for every observation. That's not going to be very useful, but just to kind of show you like the procedure of, it's probably good practice to type all of your code out in this do file and like run the code from that do file, and then you'll see the output, or you'll kind of see it being ran in the actual program. Okay. So that's how we kind of get into Stata. That's kind of how we'll start using it. I'm just trying to go real slow, kind of, the difference between the actual program, the data browser, and then now we have this do file where we can kind of save all of our code. So I'll try to go through this real slow. We'll review this again next class. We'll start talking about means, standard deviations, kind of some review of basic statistics, and then we'll see how do we get these basic statistics from Stata. So your job before next class is to try to get Stata so that you can open it up and at the very least kind of just get the program here. If you can't get files open or anything like that, don't worry about that for right now. I just want you to go through the cloud storage, IU Anywhere, make sure whatever your device you're going to have in class that you, or we're going to work on outside of class, that you can get this program and access it, okay? Any questions for me before we get out of here? Okay. So I want to say on the I know this is a lot, so I'll try to go slow. I also had something I skipped over because I know I can always win brownie points this way. I will try to get back to you guys if you send me emails as much as possible between the hours of 8 and 4. So I've got my office hours. My GA will have their office hours. I will try to be pretty responsive with emails throughout the day. I also have a 2-month at home. So I have a baby, right? So I have operating on less sleep than I'm used to. Once I get home, I generally leave the office around 4. I don't get to check my email as much as I used to, right? So I'm still adapting. I'm getting used to this new thing. So I figured baby photos can never, make someone mad at you. I got the side eye there that I get occasionally. And then hopefully you guys don't hate me too much. But before I taught here, I went to the rival. So he's a little boiler for right now. So give me a little bit of grace. I'm still kind of figuring out kind of my outside of 8 to 4 p.m. schedule, being able to respond to emails very quickly. But I'll do my best to kind of get back to you if you do contact me outside that time. Okay. All right. Hopefully semester gets off to a great start. I'm excited. I like this class. It's fun for me. So hopefully you guys find it fun. We'll start working some data sets. And I will see you on Thursday.